The title today is Geometry 11.7. And we are going to start with number 2. And there's a 3D figure in number 2. I'm going to attempt to draw it, but as usual, my 3D pictures are not so fabulous, but here we go. So it's got a hexagon in the front, and then a hexagon in the back. And then it's connected to make a 3D figure. Whew. Okay, I'm really messing up now. Try again, but I'll probably mess this one up too. It's got a hexagon in the front. It's got a hexagon in the back. So now you can kind of see it. Still not good, but see the hexagon in the front, hexagon in the back, and then rectangles connecting? Yeah? All right, thank you. So then this is 4 inches here, and this is 9 inches there. And part A says find the volume. So we have a couple of volume formulas. One of them is capital B times H, and the other one is 1/3 capital B times H. And the way you decide between them is you decide whether there are 2 bases or 1 base. So does this 3D figure have 2 bases or 1 base? 2, good. So that means we're going to use the volume formula, capital B times H. And remember, capital B stands for the area of the base. So it depends on what shape the base is on how we're going to figure this out. If the bases were circles, then we would do pi r squared for the area of the base. Or if the bases were triangles, we'd do 1/2 BH for the area of the triangle. So next step is to decide what shape the base is. Now this figure is a little bit confusing because there's a rectangle on the bottom. So it kind of looks like maybe the base is a rectangle, because usually when we hear the word base, we think bottom and top. But this one's on its side. The hexagon in the front and the hexagon in the back, those are the bases. So when we're going to find the area of the base, that means we need the formula for the area of a hexagon. So how do you find the area of a hexagon? Yes. Good. So 1/2 times perimeter times apothem. That's the formula for the area of a hexagon. Well, it's a formula for the area of any polygon as long as it's a regular polygon. What's a regular polygon again? Yeah. All sides and angles equal. Okay, so it turns out that this hexagon, it says in the directions, this hexagon is regular, all the sides are equal, all the angles are equal. So that's why we're allowed to use this formula for the area of it. So we have to figure out the perimeter. Well, one of the sides is 4, so the perimeter is just going to be 4 plus 4 plus 4 plus 4, etc., etc. So 24 for the perimeter. They're all 4 just because the directions say that it's a regular hexagon. So that's how we know all the sides are equal. They just had to label one of them. So the perimeter is 24. Okay, then the apothem is what goes there. And the apothem, remember, goes from the center of the hexagon, and then it has to be perpendicular to one of the sides. So that's an apothem. It's easy to get that confused with this line. That's not an apothem because it goes to the vertex. The apothem has to be perpendicular to the side. So that's given in this problem. It's 2 times square root 3. So this is what we're doing, 1/2 times 24 times 2 root 3. This is figuring out the area of the hexagon. So 1/2 times 24 is 12, and then 12 times 2 is 24. So these three numbers multiply out to be 24. I could multiply the root 3 times that, but I would get a nasty decimal. So I'm just going to leave it as 24 times root 3. So that's the area of the hexagon. And the reason we figured out the area of the hexagon is that's the base of this figure. So that's the capital B over here. So 24 root 3 is the area of the hexagon, which is the base of the 3D figure. So that's the area of the base. Then to figure out the volume, we just take that number and multiply by the height of the figure. Now when you hear the word height, you usually think up and down, but the official definition of a height is it's the distance between the bases. We have the hexagon in the front, we have the hexagon in the back, those are the bases. The distance between those is 9. So that's kind of weird. The 9 is the height. Kind of counterintuitive, because you think of height as up and down. All right, then you take the 24 multiplied by the 9, and that's 216. Again, I could multiply 216 times root 3, but that would give me a nasty decimal, so I'm just going to leave it like this. What would the label be? Yeah. Cubic inches, right? Because we're measuring how many little cubes, how many little blocks would go inside this figure. That's what volume is. So it's that many cubes would fit inside this 3D figure. So then part B is asking us to find the surface area. So same picture, except surface area. So when you find the surface area, that means you have to add up all the outside areas. So that's going to include the hexagon in the front and the hexagon in the back. And we've already got the area of the hexagon. So 24 root 3 plus 24 root 3. So we're finding the surface area, which is the area of all the outside figures. So far we've got the hexagon plus the other hexagon. Now again, with my terrible picture here, you might not be able to tell, but what other shapes are there besides the hexagons? Yeah. Rectangles, good. There's a rectangle on the bottom, right? And then one on top. And then there's a slanted rectangle on the side and another slanted rectangle on the side. And then on the other side, same thing. Slanted one this way, slanted one this way. So I think that's a total of 6 rectangles. Is everybody seeing? Even you can't see it in this picture because this picture is terrible. But is everybody seeing the 6 rectangles? All right, so we just have to figure out the area of each of those rectangles. The rectangle on the bottom, it's a bad line there. There's the rectangle on the bottom. It's 4 times 9. So the area of the rectangle on the bottom is 36. And the other ones are all the same, right? Because this is 4. So that rectangle is 4 by 9. So we just have to add up 6 36s for the 6 rectangles. So there's one of them, 2, 3, 4, 5. So I got the hexagon plus the other hexagon plus rectangle number 1, rectangle number 2, rectangle number 3, rectangle number 4, rectangle number 5. Oh, I don't have enough. 1, 2, 3, 4, 5. Plus rectangle number 6. So 6 times 36, that adds up to 216. So that's this plus that's the 6 rectangles. And then 24 root 3 plus 24 root 3 is 48 root 3. So the surface area is 48 times the square root of 3 plus 216. Again, I could multiply 48 times square root of 3, but that would give me a nasty decimal. And then I could take that decimal plus 216. It would give me an approximation. That would be okay. But I'm just going to leave it like this instead of dealing with that decimal. What would the label for this be? Surface area. Is that a stretch or a hand? Okay. What would the label be? Square inches, right? Because when we're doing surface area, we're counting how many of those, if they were stickers, how many of those squares would cover the outside of the figure. That's what surface area is. All right, next one is number 4. So here we have a triangle. What kind of triangle is it? It's a right triangle, good. Can't tell if it could be isosceles. Maybe the two of the sides are the same. It doesn't look like it, but we don't have enough information to know. But it's a right triangle, right? It has a right angle. So that's good news because we have a lot of formulas that work with right triangles. Pythagorean theorem, sine, cosine, tangent. Now in this particular case, they gave us the angle. So we're going to use sine or cosine or tangent. If they had given us this side, then we would use Pythagorean theorem. But since they gave us the angle, we're going to use a trig function. So x is across from 90, so that's called the hypotenuse. And 9 is across from 50, so that's called opposite. So we've got opposite and hypotenuse. We're picking between sine or cosine or tangent. Yeah. Yeah, good. Opposite and hypotenuse is sine. So I knew we were going to use either sine or cosine or tangent based on the fact that it was a right triangle. And because they gave us an angle. And then I'm picking sine because the sides we're working with are the opposite side and the hypotenuse side. That's why it's sine. All right, what goes after sine? Yes? Good. The angle goes after sine. So then sine is followed by 50. And then you write down the fraction. Sine is opposite over hypotenuse. So in this case, it's 9 over x. So now we have the setup. And we're eventually going to figure out what x is. So what comes next? Yeah? Got to figure out what the sine of 50 is, right? The calculator knows, or your trig table knows. Yeah.
You just want me to give it like over 10,000 decimal.
Give me the decimal, and then we'll figure that out.
0.6
Okay, cool. So the first four numbers are 0.7660. So he just pressed sine of 50 in his calculator, and that's what he got. We'd prefer it to be a fraction, though. So this is tenths, this is hundredths, this is thousandths. So that number is 10 thousandths. So to make it a fraction, we're going to write 7,660 over 10,000. And then that apparently equals 9 over x. Then you do the cross products. 9 times 10,000 is 90,000. 7,660 times x is 7,660x. And then you divide. It's 11 point something.
1.75.
Thank you. And I had to round that, so that's why I put it approximately equals down here. That's a squiggly equals on purpose, because it's not the exact right answer. So remember, what this means is somewhere there's a huge triangle with a 90 and a 50, where the opposite side is 7,660 and the hypotenuse side is 10,000. That's what the calculator was telling us. It was saying, hey, there's a big triangle that you could draw that looks like this. And so what we did was we just took this big triangle and scaled it down to our triangle, because this triangle was similar to this triangle. The reason it's similar is because they share two angles, 50 and 90, 50 and 90. So that's how we know that's a scaled down version of this triangle. And that's why the fractions are equal, because similar triangles have equal fractions. We just took the big fraction and scaled it down to our version of it to figure out what the x would need to be. Doing okay? Thank you for listening.